Algebra 2, Chapter 12, Section 2, Working with Polynomials. So let's talk a little bit more detail about polynomials. Polynomials have a standard form, and in standard form the polynomial is fully expanded and put in order of power. So the highest power of x comes first, and the next highest power, and so on. Finally, at the very end, you have the lowest power, which is 0. This I don't know why this is a p. This should be a 0. A sub 0. The constants a sub 0, a sub 1, all the way to a sub n are the coefficients. So these are the coefficients. They're numbers. They can be 0, so they're any numbers. Coefficients are constants. The only coefficient that can't be 0 is the first one, because then we wouldn't have a leading term. The leading term, a sub n times x to the n, is the monomial term that has the highest power in the polynomial. And as I pointed out, a sub n can't be 0. The other coefficients can. The degree n of a polynomial is the power of the leading term. So if we have 6 as our leading term's power, then the degree will be 6. If we had 3 as our leading term's power, then the degree would be 3. The constant term is a sub 0, and it is also the y-intercept. So this is important to remember. A sub 0 is the y-intercept, or the value that the function has when the input is 0. So the output when you put in a 0 of any polynomial will be the constant term. That's because every one of these other terms has a 0 in it, and they'll all multiply to 0. We give some polynomials special names by their degree. So a 0 polynomial, when p of x is equal to 0, then it has no degree because there's no monomials at all. And so the degree is undefined in such a case. The constant polynomial, if p of x is just some constant a sub 0, that is a polynomial of degree 0. The linear polynomial, which we talked a lot about in the form of mx plus b, the linear polynomial is the degree 1 polynomial. The quadratic polynomial is degree 2. ax squared plus bx plus c was the way we talked about that polynomial a lot. And we also have special names for degrees 3, 4, and 5. 3 we call cubic, 4 quartic, and 5 quintic. Give the degree of a. 4x to the 5th minus x cubed. So to get the degree, all we need is the highest power, which is 5. So the degree is 5. And the special name then for this kind of polynomial is quintic, per the previous slide. And we're used to hearing quadratic and linear, so there are some special names for the 3, 4, and 5. And there's a special names past that are used seldomly. Normally after 5 we just start to say a degree 7 polynomial or degree 13. b, the degree, so we have to find the highest power of x. So this is a little tricky. We have these parentheses. So if we think of multiplying out this right-hand side here, we have 3x cubed minus 3. So the highest power will still be cubed. Minus x cubed plus 3x cubed will still be an x cubed. 3, which the special name for 3 was cubic. This one we need to think about how we would distribute this out. Don't actually have to do the distribution. We have to think about it though. So remember, squaring means multiply that term by itself. So we're squaring the things in the parenthesis. So we're multiplying it by itself. So we'll end up, the highest term, the highest powered term will end up when we multiply all of these right-hand pieces of the binomials together as we distribute. So there's a lot of things to distribute out, but we're going to have the highest power when we multiply x minus x, by x squared by x squared. We're going to get minus x to the 5th. So we're going to end up with a degree of 5 for part C. Part D, we have a constant, and it's not 0, so the degree is 0. Remember, it's like multiplying by x to the 0 degree. So let's do some more examples here. Every year on his birthday, Elliot's parents invest money for him at an annual interest rate of R, starting with $500 on his 15th birthday, $600 on his 16th, and going up by $100 each year after that. A, if R is 4%, what is his investment worth on his 21st birthday? So 4% would be a growth factor of 1.04. Okay, so if R is 4%, then he would have, on his 21st birthday, he'd have that first $500, and he would have had that invested for 6 years, from his 15th birthday to his 21st birthday. So he'd have 1.04, the sixth power. On his 16th birthday, he'd have $600 invested for 5 years. On his 17th birthday, he'd have $700 invested for 4 years. On his 18th birthday, $800 invested 3 years. On his 19th birthday, $900 invested for 2 years by his 21st. And on his 20th birthday, he would have had $1,000 invested for 1 year. And then on his 21st birthday, he'll get $1,100, and he'll have invested it for absolutely no time, 0 years, which of course just becomes 1. So we need to multiply all these out, add them all together to find how much he gets. So adding all of this up, we'll find out that the amount of money that he has is $6,194.88. Part B. If x equals 1 plus r, which would be the factor b, then x is the annual growth factor. Write a polynomial in x for the value of his investment on his 21st birthday. So we would have 500, and instead of 4%, we would have 1 plus r, which is x, to the 6th power on his 21st birthday, plus 600 x to the 5th, plus 700 x to the 4th, plus 800 x cubed, plus 900 x squared, plus 1000x, plus 1100. Find the degree of the polynomial and interpret it in terms of the investment. The degree is 6, and it's the number of years since the start of the investment. Identify the coefficients of the following polynomials. So here we have, for part A sub 3 is 2, a sub 2 is 3, a sub 1 is 4, and a sub 0 is minus 1. So when we identify the coefficients, we'll want to put the different a values so we can keep them straight. For part B, we have a sub 5 is 4. A sub 4, there is no x to the 4th, so we write a sub 4 is 0. Remember, only the first coefficient can't be 0. A sub 3 is minus 1. A sub 2 is 3. A sub 1 is 1. A sub 0 is 1. And then for part C, we have x squared, so a sub 2 is 1, because that's implicit. And then there is no a sub 1, so 0. 0 times what x to the x would be 0. And a sub 0, also there is no a sub 0, so 0. Consider the following polynomial. What is the degree? Well, looking at the powers, it's 17. Write out the terms a sub n, x to the n, and a sub n minus 1, x to the n minus 1. So a sub n would be 13, and x to the n 17. A sub n minus 1 would be negative 9, x to the 16th. What is the value of a sub n minus 3? So 17 minus 3 is 14, 4x. I'm sorry. Just the a is just the coefficient, so only 4. What is the value of a sub 1? Well, there's no term that has just an x, so 0. Give the constant term of the following polynomials. And these may look hard, but these are actually really fast. All we have to do is find what the polynomial's value will have when x is 0. So these terms will all be 0. You just have 4 left. B, when we put in 0 here, we get nothing out, so 0. And then C, if we put in 0 for Q, we would have -1, -2, -3. When Q is 0, 0 minus 1, 0 minus 2, 0 minus 3, which leaves us with -6. So these are really fast. You just have to think about when the variable is 0 to find a constant term. Give the degree and leading term. So A, here the degree is 3. The leading term is minus 3s to the s cubed. B, not so obvious because we have these multiplications, but the leading term is only going to be when we have all the u's multiplied together. So u times u is u squared times 2u is 2u cubed over 6. So the rest of the terms won't matter. Remember, you can split when we have all this plus. So we'll end up, let's think about this for a second, a little bit harder. So we'll have 2u cubed plus a bunch of other stuff. Okay? On all that'll be over 6. And then we can split the fraction up just like we always can on the pluses. We can have 2u cubed over 6 plus what all this stuff is over 6. We don't care about the other stuff. All we care about is the leading term. So we'll have 2u cubed over 6, which is 1/3 u cubed. And that'll be our leading term of our polynomial without having to find the rest of it. If p of x has degree 4 and a constant term of -2, and q of x has degree 5 and a constant term of 7, what can we say about the following things? I find it helpful to write out what we know about p of x. P of x will be degree 4. So we'll have some a sub 4, and actually I'm going to call it, because we have a p and a q, I'm just going to call it p sub 4 for the coefficients. X to the 4th plus who knows what. Okay? And at the end we'll have -2. And q of x has degree 5, so we'll have its leading term plus a bunch of who knows what, and then a constant term of +7. So that's the form that our two polynomials have. What's the degree of p of x plus q of x? Well, when we add all these things together, the highest power will still be this x to the 5th, 5, the higher of the two degrees. What will be the coefficient of x? Well, goodness, I just did part C. When we add them together, we'll be adding them, and the highest thing will be 5. Here it's not 5, it's p of x times q of x. So if you imagine multiplying these two polynomials together, the leading term will be q5 times p4, and then we'll add the exponents x to the 9th power. That'll be the highest power that's left, and that'll be a degree 9. And what would the coefficient of x be in p of x times q of x? So the coefficient of x, we don't really know anything about the coefficient of x. That would be in this ... stuff. So, what can we say about the coefficient of x? Well, you can really just say we don't have enough information. So we'll just write not enough information. We don't know anything about the linear part of this polynomial. I already did part C at first on accident. What about the constant term of 3p of x minus 2q of x? So the constant term is when x is 0 for both polynomials. So we can just write this equation here, or sorry, write this expression. When we put in 0 for p, all this stuff goes away. We're just left with the -2, the constant term. And with q, same thing. We're just left with the constant term. So we have 3 times -2 is -6 minus 14, we get minus 20 for part D. Part E says, what's the degree of p of x squared? So if you imagine squaring the rule for p of x, it means multiplying it by itself. So that we're going to have p4 squared times x to the 4th squared, which will be x to the 8th, so the degree would be 8. Consider the polynomial ax cubed plus 1, all squared, minus x to the 6th, where a is constant. A, what is the leading term? Well, to find the leading term, we've got to distribute this first part. So we have a squared here. We would have a squared, x cubed squared is 3 times 2 is 6. Then we have 1 times ax cubed plus 1 times ax cubed is 2ax cubed. And 1 squared is 1, minus x to the 6th. So putting the x to the 6ths near each other, we have all this other stuff, 2ax cubed plus 1. And we have a squared x to the 6th minus x to the 6th. So factoring x to the 6th out, we have a squared minus 1 x to the 6th plus 2a x cubed plus 1. So the leading term is a squared minus 1 times x to the 6th power. B, for what value or values of a is the degree less than 6? So if a is such that this becomes 0, we lose our leading term, which means that our polynomial now has a different degree. So when a squared minus 1 is 0 is when we have no more leading term because the coefficient is 0. So solving for a, we have a squared is 1. Taking the square root plus or minus square root of both sides, we have a is plus or minus the square root of 1, which is just plus or minus 1. So for plus or minus 1, either one, we would have no longer a degree of 6, we'd have a degree of 3. So the answer is plus or minus 1 would be the values of a, where the degree would be less than 6.